Next, we have Mr. Suresh Patil of Hycons for special focus on pre-treatment of feedstock. I would like Nursi to say a few words for Mr. Suresh.
Yes, I have many words for Suresh actually, not a few words, many words in fact, because I remember myself and my colleague Muthu, we were in Delhi. That must have been 2.5 months back. We were at a bioenergy conference and exhibition, and that was when at the exhibition when we were kind of floating around, we dropped into his place and we had a nice little chat. And when I went in, I really didn't know what he was doing because it was about all the bioenergy, not just CBG. And when I saw Napier Grass written out there, I got really curious. So, and here is one man I thought who can probably help me out in some understanding, because already people were bugging me a lot. Tell me more about Napier Grass. I have 100 acres. Can I plant it? And I was getting questions every day from prospects around the country. What I liked about Suresh over the 15-20 minute chat we had, and that's how I got back to him, because I remembered that discussion we had in our good old Delhi, that lovely exhibition. I think he was being very conservative in some of the things, and also he was trying to, put in a good sense of balance rather than going all over the place and saying, "Don't worry, it'll work" and stuff like that. I thought it was good. As I mentioned earlier in my introduction, we have been in the bioenergy sector for a long time, and it's very easy to say, it will work, my friend, don't worry. But we have to worry because many of these things are challenges when it comes to the kind of scale we want them to work at. I was very impressed with Satish. He had his young son as well. Both of them were slogging it out in this. So I thought, if you can come down, spend some time with us here, tell more on the pre-treatment part. As I mentioned, Hycons has been working with Napier Grass for some time, pre-treatment for Napier Grass, as well as if he's in a position to for paddy straw, it will be wonderful. Suresh, over to you.
Hello, sir. Can you hear me?
Yes, but we cannot see you.
Because the bandwidth is very poor here. I am in a hotel in Punjab, Sangrur. So
go ahead. That's fine.
Can't, actually.
We can see your wonderful photograph. We are all convinced that it is indeed Suresh Patil who is talking to us. Go ahead.
Yeah. Thank you, Nursi, for giving me this opportunity to present my work for the CBG industry today. So we just start with the slides so that we can finish up in time.
Sure, go ahead.
So Tanuj, first slide, please.
Yeah, sir. Yeah, it's sharing.
Yes, sir. So the story is, so basically I am a computer graduate, but born and brought up in the farming community and farming family. So I had that sense by birth, agriculture sense by birth. Okay. So where I studied and where I learned, and there I served is the same location where I had the ancient land. So in past, I am working with biomasses for different industries. For example, I work around 6 to 7 years for industry to supply them the biomass they need. Basically, that was eucalyptus and the hybrid subabul. Then I came into Napier Grass in 2009, where I learned that the Thailand is turning into green energy business by using of this Napier grass, and this catch my eyes that India too had potential for green energy. So I went up there, studied their grass, multiple grass research facility at their university level. I brought some samples from them in 2009, multiplied here, uh, and tried to produce the biogas out of that. So, but couldn't produce enough gas, or actually in 2009-10, the CBG industry was, say, immature. So, didn't catch up with biogas in a right potential. So, I turned the biomass into silage to supply the dairy industry. So now coming to biogas using Napier grass. Napier grass actually required some pre-treatment. What I learned in my initial days. So the pre-treatment cannot be a manual, so it should be mechanical because the biogas plant needs huge amount of biomass to be handled every day. So initially it was I tried to do it on, say, pilot level using laborers, but it was too costlier. So we look at the market where there are any readily available mechanical equipments are there. So there are equipments in the European market, but again the challenge is the European products are very costly, and second is the Europe what the whatever they had the equipments that are more suitable to their farmland parcels. The European farmland parcels are very big compared to Indian farmland parcels. So there is no efficiency and there is no point utilizing the same equipments in Indian farming. So we tried to develop the mechanical equipments that can cater the need of Indian farming farmland parcel sizes. So first we do the mechanical treatment of Napier grass, and second one is the enzymatic treatment. So next slide, please. So what are the importance of the pre-treatment of Napier grass? So the if we created increased biomass yield and methane production of Napier grass, then improve the efficiency of anaerobic digestion. There are multiple challenges as the earlier presenters discussed here in the anaerobic digestion. So we need some pre-treatment. Second, as my experience is particularly in Napier grass, so today I will just focus the Napier grass. Okay. So second is Napier grass for biogas. High biomass. Why Napier? Because the Napier grass has high biomass yield potential per unit area of agricultural land. So there are multiple claims in the market actually. Some are claiming from, say, 100 per acre per ton per annum to, say, some are claiming around 2000 tons per acre per annum, which is actually a myth or actually a fake comment or fake narrative in the market. The real potential, as we are working since 2009 and pan India, we have supplied stem cuts and actually cultivated commercial level plantation for initial days for dairy industries and now for CBG industries. So the real average can be 140 to 180 tons. In initial days, it could be only 140 tons in 4 cuts, and if we apply the LFOM that is coming out of the CBG plant in ample quantities to the Napier farming land, then it could go to 180 to 190 per acre per annum. This is what we have actually achieved at certain locations. So the high biomass yield potential, again, if it is a captive plantation, then we did not have to depend on external source or external agency for feedstock. Then excellent potential for biogas production due to high cellulose and less lignin content. Now here, the challenge is to identify the right age of harvesting. When to harvest the Napier grass? So after experimenting lot of varieties and lot of different agroclimatics cultivation practices and different ages, we tested the multiple samples. Few samples are tested at Agarkar Research Institute, where the earlier co-panelists have studied. So it shows that if you harvest at say 85 to 95 days of harvest age, depending on the season, so at that time, the TS content would be around 25%, out of which almost 95% is volatile solids, only 1% is lignin. So if we harvest too early, then there is a moisture, only very less TS, say around 15 to 16%, and 85 to 84 to 85% is moisture. So there is no point in harvesting very early stage. So we have experimented, and now we have concluded that harvesting at 25% TS is a very ideal stage for Napier grass to harvest. Then there are few multiple varieties in the market, but we have identified a few potential varieties for, especially for CBG industries. One is Pakchang one, that is more famous in India with Super Napier, Bullet, 4G, 5G, or whatever the local name may be. And another one is Biocane. The Biocane is again a hybrid Napier variety. The only advantage here is it contains little bit more sugar and more protein than that of super Napier. So the potential is, again, if the more is the sugar, more is the biogas potential. So next slide, please. So again, the pre-treatment, there are multiple ways we can pre-treat the Napier grass. One is mechanical, second one is chemical, third one is thermal. All these are already explained by the earlier co-panelist. So, and because I don't have much exposure of other say chemical and thermal treatment, I just used to follow mechanical pretreatment followed by the enzymatic pretreatment. So today I will discuss only about the mechanical and enzymatic treatment to save the time of all the viewers and the co-panelists. Please, next slide. So in mechanical treatment, actually, we break down the size of the particles. So it is again clear that lesser will be the particle size, more will be the biogas production. So actually, when we thought of pre-treatment of Napier grass, we look at nature. We look at cow, how cow can digest the grass, and we try to just copy it. We have we have not done something miraculous or invented something miraculous. We just look at the cow and try to copy it, how cow can digest the grass or any agricultural waste. So what cow does is, cow had, we all know that cow had multigastrics. So when it grazes in the farming land, she chews in very big sizes and try to finish it his meal in very less time, keeping it in one compartment of his stomach. So when he comes back to the resting period in the farm, so it again recalls it, chews it in fine particles, and at the same time mixes saliva, which is nothing but a natural enzyme which can digest the Napier grass. Same is the thing we followed here to digest the Napier grass. So while harvesting, we have invented such a harvesting equipment that cuts the stand Napier grass in the farm. Then at the same time, it cuts it into small pieces, means chops it into 1 to 30 mm size pieces, and same time loads into the transportation vehicle. So this is all the three activities can be conducted in one go by the harvester. Then that harvesting material or chop material being transported to the processing facility, biogas plant, where again we convert it, or again we conduct here second mechanical treatment that converts that biomass of 1 to 30 mm size into 1 to or less than 5 mm size. And then we add the enzyme, which we had actually it is readily available in the market. We just have we formulated it in the right proportion. And again, it is not a chemical kind of material or chemical kind of enzyme. It is a secretion of the bacteria or say fungi. So cellulose is tough crystalline polymer, difficult to degrade. Then hemicellulose again polysaccharides more easily to hydrolyze. Lignin, it's something which is hard to digest. But as I said earlier, that we harvest the Napier grass when there is very less quantity of lignin. So in case of Napier grass as an feedstock, actually we did not have to worry about lignin because it is very less in total quantity. So the complex structures limits biodegradability. Pretreatment is required to enhance digestibility and increase biogas yield. Next slide.
Next slide, please. Yep.
So these are the mechanical equipments what we have invented over the period of time in India. This one is the first blue. This one is invented at our factory in Punjab. And second one is what we are importing from Thailand for in initial days only 5 pieces, and rest that can be manufactured here in India with their collaboration to bring down the imported cost. So the process is field chopping to less than 30 size. Then at the CBG plant, again second milling to less than to bring the biomass into less than 5 size. So advantage is very cost. Now it is very cost effective solution. It increases the surface area for the subsequent treatment of enzyme and the bacterial consortium. There are certain challenges. The mechanical treatment does not break down the lignocellulosic structure of the biomass that needs to be cared by adding the enzymes. Then limited effect on lignin, cellulose, and hemicellulose. So mechanical treatment is not for treating lignin or cellulose or hemicellulose. What I meant to say here. Next, please. Next slide. Yeah. So the process is back. So the process is in the first picture on the left hand side, you can see what we bring or what we do at the farm level. So the particle size we chop at the farm level by using the mechanical equipment, what we see in the last slide, that is from 1 to 30 size. So when we bring it on the farm, so on the CBG plant, so extreme right side slide watch. When we wet milling, we invented one milling technology. We can see after wet milling of this Napier grass 1 to 30 size, we can see that it is 1 to 5 size. And the middle picture one is after the enzymatic treatment and hydrolysis for. Next slide. Tanuj, can you hear me? Next slide.
Next slide, please.
Yeah.
Is this the slide you want? The one? Okay, one before.
Yeah. So the process is again same what I have explained earlier. Just to make you pictorial or familiar with the Napier farm and everything, I prepared this slide. So you can see the picture A, how the Napier field looks like at the time of harvesting stage. Earlier, we used laborers to cut it from the bottom and used to transport in our R&D facility. That is slide B. Then we use chopper grass, small chopper grass to chop it. That is slide C. And last one is the chop material in slide D. So this is the process actually. The advantage and challenges I also discussed in the last slide. So next, please. So here I explain you the detailed process flow. So step one is mechanical chopping of Napier grass in the field up to 30 mm size. Then second stage is to transport that same chopped grass to the processing facility, means CBG plant. Third step is second mechanical treatment, means grind it or mill it to bring down the size lesser than 5 mm, which will increase the surface area exponentially. Step 4 is we add some enzyme and put it up to 370 to 96 days for hydrolysis, so that the cellulose, hemicellulose, and certain part of lignin can be degraded. And then we pump this sugar syrup kind of material into anaerobic digestion for the bacteria to consume. So this is the process. Next, please. So again, these are some pictures. So in first picture, this is European solution. What we have created miniature version of the same in India that suits or fits to the Indian farming land parcel sizes. And second one is the pre-treatment. We need 3 to 4 pre-treatment tanks to act enzyme fully in the hydrolysis process. Next, please. So here you can see the impact of the enzyme, what we have invented and what we are treating with. The bottom picture was just milling, second mechanical treatment, and above one is after 3 days of hydrolysis with addition of the enzymes. You can see the clear difference. Most of the cellulose and hemicellulose are degraded and created more liquid kind of material, so that it eases again for bacteria to consume the ready kind of sugars. And second, it facilitates the agitation also. Less power required and less chances of scum formation. Next, please. So what are the optimization factors? So here, agroclimatic influences, local temperature, humidity, and seasonal variations can affect pre-treatment efficiency. Yes, suppose in certain areas there were say elongated rainy season. In that case, the harvesting may not be possible in the farm, so the pre-treatment can be affected. But we had come up with silaging facility to overcome this challenge. Cost benefit analysis. Balancing the initial cost of enzyme with the increased biogas yield and efficiency. Suppose, so if we are expensing or putting rupees 1 for the enzymatic treatment, we are getting at least rupees 3 from the enhanced biogas production. So it is always beneficial to add enzyme in the pre-treatment. Again, potential for process optimization, reduce the cost in long term. So agitator life and everything will be increased because it consumes less power and less stress. Next, please. So its last slide. Combined mechanical and enzymatic pretreatment significantly enhances the efficiency of biogas production from Napier grass, results in higher methane yield and reduced anaerobic digestion time. Again, it reduces the HRT. If we don't add enzyme, the HRT could be 55 to 60 days to reap the full benefit of Napier grass. So by adding the enzyme, we can reduce it up to 35 to 40 days. And what we have achieved also. So we are again continuing with our R&D facility to enhance this process, again trying to reduce the HRT time so that we can have lesser CAPEX and lesser OPEX.
Moving on, we have Mr. Atul and Mr. Abhimanyu of Primo Engineering for special focus on pre-treatment of feedstock. I would like Nursi to say a few words about Mr. Atul and Mr. Abhimanyu.
Yep. Before that, a big thank you to Suresh. Suresh, if this is the first presentation you have ever made in your life, and this is so good, you are going to make fantastic presentations in future, because I think you stuck to your time, you focused on things that matter the most, And even some of the questions people were putting in as you went along, you answered them. Thank you very much, Suresh. I think I loved it. I think the way you are logically presented it. Sure, there will be questions. This is what this is an emerging area. I'm sure there are going to be lots of questions. People have doubts. They have raised. Some of them I will ask. But it was really good having you and such a focused, wonderful presentation. Thank you very much. Atul and Abhimanyu, welcome. This is something this is a story I should tell you guys. This must have been 2019 when I was doing probably one of the first comprehensive market research for CBG in India. As I mentioned, CBG was a terminology that had just entered the Indian biofuel lexicon. And so there was a client of mine, an NRI, who wanted me to find out everything about what everybody is doing with the CBG in India. So most of the time I was talking to guys who were doing work in MSW, food waste, poultry waste, cow dung. And then I came to know about this company which was trying agricultural residues, because even by that time it was clear the country had to move beyond the traditional feedstock if it has to scale. And then I went to Pune and I heard that this company is near Pune. Then I somehow got hold of Atul and I said, look, I need to meet you. He said, do come down if you're in Pune. But then I realized it was not in Pune, it was some distance away. I traveled in a rickety auto rickshaw. It took some 50 minutes. But boy, did I enjoy my travel. It was a lovely travel. The environment was good. More importantly, these guys had put up a lovely facility there. I don't remember all the details about that. It was a small one, but they were already doing pioneering work in pre-treatment of agricultural residues. I think they were using paddy straw at that time. I had a wonderful discussion with him. As I said, this was practically in the middle of nowhere, but not only had they put up a nice facility, he gave me a very good tour. It was a hot day, mind you, it was a pretty hot day. Thankfully, Pune is not Chennai. It wasn't so hot, but it still was pretty hot. He gave me a very good tour of the facility, everything right from the digester to where they stored stuff, as well as the separation unit. And finally, we had a good chat. So that was the first time I had actually had a good chat about pre-treatment. And when I spoke to Atul yesterday and asked him, oh, this was 2019, remember? This is five years back. Yesterday, when I spoke to him, he said, they have moved on in terms of some of the new things they were doing with pre-treatment. And Atul, I'm all here. I'm all ears to understand, know one of the first guys to start this. Where are you guys? What are you doing? And what is new about what you guys are doing in pre-treatment? Atul, Abhimanyu, welcome. The stage is yours.
Good afternoon, everyone. As Narsi just mentioned, we are relatively very old in this industry as far as research is concerned. We are into CBG research for about 15 years. As rightly mentioned by Narsi, that time it was not even christened as CBG. Ours is totally indigenous technology, indigenously developed, in-house efforts being put for 15 years, as I mentioned, and recently patented also. Now, today's topic was use of enzymes, whereas yesterday I mentioned to Narsi, what do I do? Because in our technology, we don't use enzymes. So it is much different to the other players who are going to talk about how they use enzymes, catalysts, chemicals, etc. So I would like to say, or rather state categorically, that except for physical treatment, there is no use of enzymes, catalysts, or polluting chemicals in our CBG production. The unique part of our research is, which will surprise most of the people present here, is that it's a thermophilic process and anaerobic digester, yet we use oxygenation as an process improvement. And that is the trick of the whole, or I will say USP of our process, which is called Agro gas. As the name suggests, Agro is the input and CBG gas is the output. Our Agro gas process is co-digestion possible. We have successfully tried, of course, rice for years, rice straw for years, and other combination of various agro residues in combination with rice straw. And we are getting exciting and interesting results. Currently, we are under process of doing commercial validation, and by next financial year, that is in month of April, we should be announcing and presenting our final technology to the world, which will be offering about 50% more efficiency than most of the other processes known to us in India. We are also working and on how to bring down the capex by at least 20%. Recently, I have been operated on my eye, and that's why I won't be able to show you any slides. And also to bring down the average age of our team, I have got Abhimanyu on board with me, who is a very young and talented engineer in our company. So I will pass on to Abhimanyu, who will take you through a couple of slides. Thank you very much, Narsi and others.
Pleasure, pleasure. Welcome, Abhimanyu.
Yeah.
We can go ahead. Do you have slides? Do you want to put them up?
Yeah, I believe it was, yeah. Thank you, Tanuj. Thank you, Mr. Narsi, for inviting us to present here. If you can take it to the next slide, please.
I can do it.
So I believe, coming to our topic of Napier grass, I believe it has already been covered, but just to give you an idea of a quick touch up on what Napier grass is, known for its height, vigorous vegetative growth, as it's a grass, very high yielding perennial fodder, and a very simple cut and carry type of fodder for the stall feeder systems for livestock. The ideal parameters for the growth of Napier grass are shown here, and it should be quite evident that it's a resilient crop and can grow in any part of India, as we are well aware by now. Next slide, please. A few points on the cultivation of this grass. Planting can be done at the onset of monsoon or any time of the year if ample irrigation facility is available. It has a comparatively low water requirement with an irrigation interval of around 3 to 4 days during summer. Low nutrient inputs required here, and if you're talking about like a circular model, you will be able to use the FOM coming from CBG plants as well to improve the harvest. Next slide, please. As I believe it has already been talked about by the previous panelists, the harvesting can be done in short intervals of around 4 months. We are estimated that we can get around 60 to 70 metric tons of the wet Napier grass, which will be having around 80% of moisture. This 60 to 70 tons we will be getting per acre per harvest. So that translates to around 180 to 210 metric tons of wet Napier grass per acre per year. The average total solid content or dry matter in this grass is around 20%. And to the right, we have an approximate analysis of dry Napier grass. So as we can clearly see that the ash and lignin percent is quite less. we are having higher proteins here, and because of the higher cellulose and hemicellulose, it translates to a higher digestibility, making it a very good and ideal energy crop for CBG generation. Next slide, please. So I believe Mr. Patil had already shown us some images. So we also have the same idea of bringing the ground realities of the farm to you. Next slide, please. So I believe this topic has been covered in quite detail by the previous panelists. We just thought to touch upon this topic, so we had added this slide in. So we can skip this slide. And the same here as well, we can skip this slide. I believe the overall process flow diagram is the same as what has been shown before. We are mechanically shredding the biomass. That's the only form of pre-treatment that we are carrying out. And once the magic that we are doing, which is explained by Mr. Atul, is carried out inside the digester, the downstream processes are again quite similar. Next slide, please. This is a slide we would like to focus upon. It was a good idea to understand how Napier grass is grown, what is the biology behind pre-treatment, and the other topics that was discussed by the panelists. But coming to the crux of the matter, what do we do with it? How do we make an economical project? How do we make it green? Not just in terms of environmental sustainability, but in terms of commercial feasibility. So most of our plants are of the range of 10 ton per day CBG generation capacity. For 10 tons of CBG, we have calculated a requirement of 400 tons of Napier grass, that is wet Napier with 80% moisture. This translates to about 80 tons of dry matter, from which we are able to generate 10 tons of CBG, which is a very high yield of 12.5% on dry matter basis. The secondary product that we get along with it is briquettes or green coal, which has a good calorific value and can be substituted in thermal power plants. Apart from briquettes, we have another secondary product, that is carbon dioxide. For this calculation, we have not included the CAPEX required for CO2 liquefaction, and neither have we considered the sales from CO2. So moving ahead, the projected annual sales through the sale of Agro gas, CBG, and briquette is estimated at about 31 CR. The capital investment for setting up a CBG plant, apart from the land and farming costs, is about 72 CR. Considering the central government subsidy of 8.3 CR, we are arriving at a simple payback of just under 4 years. The land requirement for such a project, for the plant alone, is about 9 acres, and the duration for setting up such a project is about 12 months. So as you can see, this is quite a lucrative project, and it definitely should bring in a new era for the CBG industry.
You see, I am getting questions. I think people are still putting in their questions because both you guys took an optimal amount of time to finish. We have about 15 minutes for questions. So we are pretty much running on time. You see, we saw two different presentations. One where Suresh had done what most of the industry seems to be doing, even though he has his own methods of doing it, where he had a mechanical stage and then a biological pretreatment through enzymes. And that was very detailed. And I must thank you for giving some wonderful inputs on data points on yield, etc. And then we have from Atul and Abhimanyu quite a dramatically different presentation where they seem to be having a technology where which is quite different for pre-treatment. Now, obviously, I have my own questions, but I'm going to first ask questions that others have asked to both Atul, more to Suresh right now, because I guess guys are just typing in the questions for Atul. So Suresh, first coming to you, you see one of the questions. In fact, there are two or three of them who had asked this question about the harvester.
Yeah.
Now, some of the questions are about, you had mentioned you are designed your own harvester, while at the same time, if I recollect correctly, you had also mentioned that there are harvesters from international brands which might also do the job well, even though they may be expensive. So they want to know, is there some way you can help these guys with harvesters if they want to? Of course, I'll send all those details to you, contact details. So they want to know about the harvesting machine that can cut and chop at field. Is that something you can connect? You can talk to them, and is this something you can share your technology with them? This is 3 or 4 people have asked that question.
Sure, sure. Sure, sir. I can connect later on. Okay.
Okay, wonderful. That is one. And the second question they had in this context was, okay, we have harvested it. I think if I remember correctly, you had said some 30 millimeter, and then you have to trash it, cut it to less than 5 millimeter. The question is, how do you ensure that it is less than 5 millimeters when it goes into the slurry? So because that seemed to be an important metric that you are using, how do you ensure it's only 5 millimeter?
Yes, sir. That we have done, say, lots of research on size reduction of Napier grass, particularly. So step by step, we have improved our milling technology. This is not a one-day kind of efforts. So it took some, say, 1 to 2 years for us to invent such a grinder that takes care of, or that makes ensure that the output coming is less than 5 size. So I can share some lab reports also, where we analyze that the particle size, almost all particle size, say 95 plus particle size are less than 95%, 5 size.
And this process that you mentioned, you have a mechanical process and then an enzymatic process. Is there a facility of yours running somewhere? Can people visit it to see the metrics that you're getting? Is that possible?
Yes, sir. Right now we are working on 7 different locations for different. We are APC company now, so we are working for. Actually, we had 22 orders in hand, and actual work is initiated on at 7 different locations, and maybe come up with first operational and commercially operational plant by March 2025 or April 2025, where we can showcase the entire end-to-end technology.
Wonderful, appreciated. But you see, this has been a challenge for me as well, even though I'm supposed to be fairly well connected. It has been a bit of a struggle to actually visit a working plant where they can show validated details for the preceding, let us say, 6 months. I appreciate you guys are all in the initial stages. So this is a question even I had, and the same is the concern that many of these guys, we have how many, 130 people, many of them are wanting to invest in this. They also have, look, it is all fine, you guys are doing a great job, but I cannot invest without having validated results for a sustained amount of time. And you guys are saying, okay, look, you've done all the homework, but in terms of the working facility, it will be available only in somewhere around middle of 2025. Is that what I hear from you?
Yes, sir. Before that, we had one research facility where we have conducted all these trials, physically, but it is very small capacity, no. And again, it is created for to handle all kinds of different feedstocks available in the market. So to showcase it is not worth, because it is not something say fancy kind of facility. If someone who is not aware of the CBG industry visited and saw, he will never go or never enter into CBG market. So that is that operated kind of human body, no. So same is the our
Fair enough. Fair
facilities.
enough.
Yeah.
Fair enough. So I appreciate, but the answer from your side is this will take some time. They cannot
Yeah, yeah,
present it
yes.
tomorrow. It will take maybe 4 to 6 months. Correct?
Yeah, yeah. By March we can showcase. Yeah.
Wonderful. So those
And
are some
at
questions. Yeah, go ahead. Go ahead. Go ahead, Suresh.
by March, we can have around 2 to 3 facilities or 2 to 3 plants, maybe made commercially operated.
Okay, wonderful. I'll come back to you, but going to Atul and Abhimanyu. So it was a good presentation. I think it was a good overview. But I'm just curious, what is it you guys do? You are you saying you just do mechanical and that's about it? So there must
Yeah,
be something happen. You must be knowing something. What can you tell us? You may not want to tell us everything. What can you tell us? What is it you're doing that is getting rid of pre-treatment with enzymes? As Atul said, as Suresh said, it looks like enzymatic. The enzymatic stage is a fairly important stage, or for that, if you don't do enzymatic, maybe thermal, maybe whatever else. But what is it? What is the secret recipe? At least some idea about
yeah.
what you guys do.
Then see, as I mentioned, that we are in agrogas, that is CBG research for last 15 years. And by 2016, we successfully established our proof of concept plant at place Pirangut, Pune, which is about 15 kilometers. Those days, travel must have seemed to be very long because of the summer. But
Hmm.
nowadays, thanks to Gadkari ji, our state government, it's a 4-lane road and you can reach there just in a jiffy.
Good, good.
So
I wish I had come now. That day, I think it
most,
took me for 1 hour.
most you and all the people are most welcome to come and visit our facility. So in 2016, we did demonstration of our agrogas technology, for which we were, I must admit that a small company, technology company like Primo, where two of the India's big ministers, late Manohar Parrikar and Gadkari ji came, and they were totally taken by surprise when we showed CBG being filled in municipal corporation bus and taking them for a round in the nearby area. Having done that, we did not want it to be just me too technology players. So we went to the drawing board, finalized our 5 TPD, 10 TPD plant design, and today what others are offering plant, we were ready in that position just prior to the COVID period. But we were not satisfied with whatever was happening around. Our focus was to still bring down the capex cost and lower down the opex cost also. The pre-treatment, even the mechanical, was a big issue, and a lot of electricity was getting consumed in that, and therefore our efforts and research were directed towards that. And just now, I will not give it on stamp paper, but by March, we will propose to the CBG segment that your particle size in our technology doesn't matter at all. And with that, all your those imported equipment and these things, shredding machines, etc., are out of the process, which will bring down cost by almost 20%. About 10 to 15 crores capex will be lowered, and that will make this plant highly appealing to the investors. So all the investors on the those who are listening now, let them start doing the paperwork or ground level work now get ready to set up their plants in April next year. Now,
Go ahead, Atul. Go
okay,
ahead. No,
what we have done,
my question
what
was.
we have done,
Yeah, go
what
ahead.
we have done with technology is totally out of box. Now, who would have imagined, which microbiologist would have told you that you can use oxygen in anaerobic digestion? Isn't that weird to the
Yeah,
ears?
it
And
is.
that's what we have done.
It is an
And
oxymoron.
correct, that's what we have done, and that's why given us these fantastic results. And that is why our patented technology, AgroGas, is going to be in the forefront of all technologies next year onwards, with results around at least 50% more than CBG output than conventional technology. So conventional technology, what we are discussing in this today, as Suresh mentioned, we were ready in 2016. Some of the plants have also started coming up on that. But those plants we are altering to our this new invention to bring down the capex as well as opex.
Very good. So let me ask one question, actionable question, Atul. You see, we would all love it if somebody comes up with a disruptive innovation. What can investors do? What can they do? Can they come and meet you? Are you available to have a long, detailed discussion with them? Tell them whatever they want right now, or do you want them to come to you sometime later?
They can come right now also.
Wonderful. Very good. That's the best, shortest answer I have received.
So only suggestion I will give that let's make a new beginning in the new year,
Fair
because
enough.
now since it's a holiday time,
Fair enough.
so
Fair enough. We will ensure that you have your holidays well, and I request all the investors in this team. Yeah, you guys have your holidays, enjoy your holidays, and let Atul and his team enjoy the holidays after January. So you're welcome to meet him. Thank you, guys.
yes,
Thank you, Suresh and Atul. Wonderful talking to you. There are lots more questions, many of them very specific. Once again, to all the audience, don't be disappointed that your question is not coming up. I'm telling you, we have a team which is going to work on this for at least 50 to 20 days after the event. Each and every question is going to be indexed along with the person who asked, and they are going to be sent to all the relevant experts who spoke here. So you are putting your question into the right box. So put as many as you want. Folks, thank you very much, Atul and Suresh and Abhimanyu. Thank you very much for your time. Tanuj.
thank you, Narsi. Thank you, Narsi.
Yeah, thank you, Anuj.
Thank you. Thank you.